Okay, so my session is I'm going to talk about programming your own autonomous drone, and in combination with two things. One is Droneblocks to get you more into like the mathematical principles that you need to know if you're trying to program a drone, and then using Python to make it more interesting. And do a little bit of trying to do some image recognition if all works out. So let's start a drone, right? And two things before in the agenda. I'm going to talk about the types of programmable drones out there. So what types are there? What tools there are available to program the drones, and also showing how to program the drone itself. So a little bit of demo about Droneblocks and some code samples in using Visual Studio Code and compiling the Python code and running it on the drone. And I'm using DJI Ryze for this, or the Ryze Tello for this. I brought this because this can be broken, or if it breaks, then it doesn't matter. I could also have brought my DJI Spark or even the Mavic Pro, because they all the DJIs and also the Ryze, they use the same engine on, at the back end, so it can be programmed all the same way. We'll show that in a moment. So for people that don't know me, my name is Robert van Mölken. I'm currently solution architect at Ryze. We're doing a condition monitoring project there based on the IoT. But for 12 years, been a developer before that. I'm a groundbreaker ambassador at Oracle. So that's if you know the Java Champions, it's a different program. Beside that, last year it was called Developer Champion, and then they changed the name to Groundbreaker Ambassador. Bejan is also one of in our group. I wrote 2 books, one on integration cloud and one on the past 2 years on blockchain. Was released last October. So if you want to do development and implementation on blockchain, it will give you the overview of all the concepts, and then even doing implementation and smart contract development and things like that. But today, right, let's talk about programmable drones. So there are a lot of programmable drones out there. You can then, the commercial ones are there. The big players like DJI. DJI has a lot of series, so the Spark, the Mavic, consumer-based drones, and then we go to the more bigger ones like the Phantom and Inspire, and even the Matrix, and also is even a hexagon drone, and they offer, if you want to program with them, they offer a lot of SDKs. They offer mobile and UX SDKs, also even for Windows, and they have specialized SDKs to even do onboarding and condition monitoring so extending the functionality of the drone itself. And DJI is one of the drones you can program with Droneblocks. The other one, that's the one that is Parrot. It was a big consumer drone company before DJI won the war. But they have like mini drones you can program, like the Mambo and the Swing. The Mambo is really a drone, and the Swing is like an airplane. They can be programmed with Droneblocks, but they have their own a program called Tinker, but it works like the same way. And they have Python and JavaScript SDKs also. Then we have this little drone. This is the DJI Tello, and you can program them using Python, JavaScript, Java, but also they have a Go SDK, and there are some apps like Droneblocks, but also even with using Scratch you can program this drone. It works on and Droneblocks works on iOS, Android, and in the Chrome browser, so that's from like your laptop and Mac or Linux or whatever. And the new one on the block, and this is an Indiegogo project that I think ran in the beginning of the year. This is the Pluto X, and the Pluto X is a board with already the cross on it, and you get the motors and everything on it. Yeah, it's a 3D printed casing, and with that, they have a different approach. They use an API-based SDK. So and in combination with the IDE. So what you do is you program code, and then you push the code to the drone, and the drone flies itself. Where the other ones, they use like they use the Wi-Fi signal. So you have a gateway connection to the drone itself, and then you program the commands, and that will fire the commands to the drone. So that's what we're going to see today. If you look at use cases, and it's fun, of course, this drone, but you needed to see it in a broader picture. So the project I'm doing at Erics, we're doing condition monitoring. And we're doing that in factories. Because Erics is build pumps, they build engines, they build drivetrains, stuff like that. But if you look into the field where the real use cases are now, as in if you want to have a humanitarian aid, so if there's a fire or there's something on, then you can send that drone on a flight path, GPS flight path, and streaming the video of it back to like the receiver and do actions on that. The same goes with construction planning, knowing what are the changes currently happening and making, of course, the shots, the pictures and stuff like that. Other thing is, an interesting one is in the wildlife conservation. In South Africa, in the reserve, they use drones to track the migration path of elephants and other animals, and they do the accounts of what they see. So they use a combination of the object recognition to see, okay, this is an elephant, and we count it, and they know the location based on the use of like the GPS of the more expensive drones or the Spark even. This one doesn't have any GPS, so this is just for breaking stuff, right, and playing around for this kind of presentation. So other use cases where you see things where this being held isn't almost on the things defense, of course, where you have drones with weapons, but also emergency response. If you're, for example, go skiing and you go with your car up the mountain and your car breaks and you don't have any. And there's not emergency services or somewhere you don't know where you are or whatever, but you have a proximity. They can send out a drone and figure out where you are, right? But if we look at an example, so will it? Nope. I need to, okay. Yeah. So what you see here is the drone flies, and this is used based on the Tello. It sees the video coming in, and then based on a library called YOLO, it's used to do like the image recognition on the cars, on the vehicles, and also on the people. So this can also be used to track like those elephants, right? If you have like a model that knows what's an elephant, it works on the same way. And based on he's now flying in itself. But if you have a certain animal you're looking for, it can also maybe fly it autonomously or whatever what you do. But so it can be two-way, right? Now I'm streaming the data, I know where it is, and from there on I can send on data back. And this is done even with the Tello, and then in a combination on your back end. So your back end, you have maybe use OpenCV, or you use, or you can send it to Amazon and do the calculation, or maybe to IBM Watson, to offload it to somewhere else where you have calculation power, right? Instead of running it on a Raspberry Pi or your laptop or something like that for the constant connection. And then I need to go back to my stuff again. Okay, yeah. Okay, so the tools for the job. Of course, the Tello already said that. This one is very easy to fly. It's made for just fun, for speed, for doing flips, for things like that. Right? It's not using for commercial purposes, but it does the job right now. Droneblocks, I will show you that. Droneblocks is a drag and drop programming environment. It looks like the same like Scratch or things in that order. And it supports many of the DJI drones and also the Tello, so you can switch between that. And we will see that in a moment. There are differences in using the DJI or the Tello. We have a Python SDK, and in combination with Visual Studio Code, we can do much more advanced scenarios. I will show you, try to show you a demo using object recognition or pose recognition. We'll see that if we get it to work, but else I will show you the code, how it talks to the drone, what are the commands, how what it's processing in the terminal and console, and we have an indoor space for this one. So this can only be flying best indoor. You can fly it outside. You have bigger space, but then you need to. If it flies over water, it can't fly over water. So there are some limitations also there. Okay, so this is the Ryze Tello itself. So it has some smart sensors at the bottom. With this, it calculates where it is. It knows the height and if it's run over water or not. If it detects water, then it will fly back. And it can be used to, the problems it has is with if you have a wide floor, then it stabilizes not that great. So here it worked decent. So we'll see that. Yeah, it has failures and stuff like that. So it has some things. Of course, a camera at the front, so it's a 720p camera. But for image recognition, that's good enough. And you can make pictures and stuff like that. So you can make a snapshot of what you're seeing. This is how Droneblocks look like. What you have here is a lot of actions you can take. This just play around, just get a feeling about what you can program at the end. Where we can do takeoff stuff, some navigation. With navigation, we can do even program curves. So not only go forward, backwards, and stuff, and up and down, but you can even set curves and sinuses and things like that. I will have examples for that in a moment. Where you have some logic, some mathematical, you can define variables. And if you want to have the code, because there's also, this one is using JavaScript to talk to and do the conversion with the gateway, you can use this code, and then use it like in JavaScript or Node, and then it can do the same. But just an example in the code, what it does, that you know that you program something the right way, even in the blocks. There's one thing that you can't do, is change the code at the right and then have the blocks at the left change. That's a little bit disappointing, but you can't do that. There's a difference with DJI. So the Tello is the first one, and the DJI. The DJI can't do flips. It's not a sport drone, but they have a better camera. And what you can do is change the gimbal. You can make photos directly from here without you need to use of Python. So with Tello, it's only commands sending to the Tello. It can't listen back. And with the DJI, even with the DJI Spark, you can listen back. So what are like more advanced things to like try with this? If you want to really fly autonomous things, you're gonna program it from outside, run something, code on it, or run Python or whatever. With Droneblocks, you can try out the more advanced fly routes. So this is really easy. There's a formula to know how to fly a 360, but based on the many angles you want to fly. So if you have like a hexagon in the middle, then with this formula, n-2, and then the 180 divided by n, you can have it knows how many sides, but it knows the angle it needs to, the amount of degrees it needs to turn every time. So this is a little bit about the code, what it looks like, real small maybe from the back, but it's already, to do this, you already need to set some variables, you already need to have some loops in it. So even for the easy way, you can define blocks like that, and it makes it more like interesting. Other thing is you can fly a sinus, and a sinus is like doing this, and it will take this code already. So it's not like for that it's easy to program itself. You need to have like some kind of mathematical and science knowledge how to do stuff like this. So there are just a lot of formulas for that you can implement also with this. But it is not one block, right? It takes some time. But what this does, this drone does, is it takes a position, and then it will go up, and then it will curve. So it's not like it will go up and then down. It will fly a curve, right? But to do that here, I need a lot of space, so I won't show this one. So this is the one I'm going to try to show you. This is a 360 view. And this is interesting if you have like maybe some object you want to inspect from all sides. And maybe you have like a wind turbine that you need to inspect if there's something wrong with it. And what you can do is like said, okay, I need to fly out a certain diameter, then it turns back. And then I have said in this code, I want to have like 12 photo moments. It calculates the 360, divides it by 12, then it knows how many stops are, the angle it needs to take, and things like that. Every time it has, instead of, because I can't do photos with the Tello, I just hover to let you know that's the moment what it takes the picture. But it will hopefully, with the door closed, will fly this 360. But it depends on wind, how the wind goes. I tried it at home in my bedroom, and there it worked. But let's see if it works here. That's always the So I will try to show you that first before I get into the more interesting stuff. So this is Droneblocks, and not this. This is. Well, I need to duplicate my screen. So this is Droneblocks. So in Droneblocks, what you have is. Don't make it bigger. Okay. No. Stupid. Okay. It was better right now. Okay. Nah. Fuck it. That's so this the code of this. I can zoom in, of course. Yeah. So what you see here is that you in the start you always have a takeoff block, and the takeoff block is something you can select and then drag and drop and then and put it there. So every block you do, you can append it at the bottom, or you can, if you have already some code and you want to do a loop around it, you can pick the loop and set the loop around it. What you see here is that this is in inches, and this is because inches, it's easy to calculate because it's much more. I can also change it to 90 centimeters. But then I need to also change like the height and stuff like that. It's easier to have lower numbers and even numbers. So I will do a photo count of 6 because 12 photo counts takes a lot of time in this presentation. You can set some variables, and what you do is you can create variables here and give it a name, and then it will be added here, and then you can have like a set or something like that to change values or increment changes by 1. So there's a lot of things you can choose. You can do logic, so an if else with calculations, or you can do like mathematical checks. So it's the same like that I can see this value is even, or it's the sinus or the square root or something like that. You can do that. So what it calculates the distance per photo count based on the radius. And then what it will do, it will fly, after takeoff, it will fly up 20 inches. So it will be around here. Maybe I will set it to 40 to even be higher. And then what it hovers for 5 seconds. And that's usually with this, if you want to do like changes into in two sides, it's better to hover for a moment so it knows what the position is to the ground. And then with that, we do the first change. It does a 180, so it points to me, and then it will do the photo count. So it will take those 360, and then it will go around till it's done. And let's do a cool stuff at the end before we're gonna land. Let's do a flip backwards. Yeah. So now that I'm connected, I've turned down the drone. So I'll put the drone on. Let's try to put it. I need 90 centimeters, right? So maybe go up a little bit. So hopefully it does. So don't be scared. We're in the Netherlands, right? So if I couldn't do this in San Francisco in last year because of children and liability in the US. So this is the first time I'm trying to fly it. You can't see me right here, so I don't. Okay, so what we need to do here, it's if it's on, you will get it will get Wi-Fi from it. And is it on or not? No, right? Yeah, it should be. And also I need to put in a different Wi-Fi. Okay. Ah, it's here. So it's the Tello is connected there. So try to connect it with the Wi-Fi. Now this is an open Wi-Fi, but there is a command in the SDK to set its own SSID and password. So yeah. So it's connected. So you can't like start Droneblocks, the application, if you're connected to the Tello because it needs internet connection. Come on. Yes, okay. So what now can do is at the right corner you need to connect to it. And if you're changing Wi-Fi, you need to really reconnect. So if you reconnect, you see the light turns green, right? It's not yellow anymore. Okay, so, and now we can, at the right corner, we can say launch mission. And now it should go up, right? It will go forward after 5 seconds. So now tries to hold its position for 5 seconds, right? Ooh. Okay, so now it turns 180. And it tries to do the loop for 360. So, and what I've programmed in is that at every time on a uneven picture, it will go up, and in an even picture, it should go down. But you will already see that it has issues with trying to do the 360, right? Yeah. And the main reason is because of the ground itself. And I did a test before you all came in, and I saw this also happening. I was thinking maybe it's the wind from the door, but it doesn't fly. It doesn't fly this way. You only see the turns, right? So that's a pity, because it's there, distance, right? Yeah. So the last thing is the flip, right? So if it should be turning that way, right? So it does a flip back. It's almost done, right? It's only one. Okay, right? So it's now watching you, right? Okay. So this is the last turn, right? Yeah. Okay, and now it lands. So what it does is, yeah, it didn't do the 360, but in flying around, that's pity. But so what it does right now is every command that's here, I connect to the Wi-Fi, and it uses a UDP port, so it has its own IP. It has a port, and then with UDP, it sends commands, string commands to that. To the drone to execute it. So it's not in parallel, it's not sending this code to the drone, it sends the commands after each other to the drone. And how you would know this for yourself is if you do it the different way around. And the different way around is going for, so this was the example we saw, right? I've still got 25 minutes, so we don't need that. Okay. So the other way around is using a Python SDK, or if you want, you can go for Go, or for JavaScript, or Java, or whatever, because it's using a UDP port, so there's a lot of people that saying, I don't want to use Python, I will build my own, right? So there's a lot of stuff there. There's a lot of wrappers made by developers. And if you want to have the official SDK, so without knowing what the code is, just like these are the commands and connect to this port and how you do that, there's a link there in the presentation. I will share the slides so you can look at that. That's the official SDK documentation. So the commands that are available are the takeoff and the land, of course, right? Then we have flying in a direction, like forward, backwards, left and right. You see those commands back in the code in a moment. Then we have go up and down. We have the rotate, that's the yawn, and that means it tries to change on its spot, on a degree. And the curve. And the curve is much more that you can say, I want to go from this axis XYZ to this XYZ. And then it goes up and down. Then the flips, forward, backwards, left and right, we will see that. We have seen that. And video streaming on and off. So if you do stream on, what you can do is listen to the UDP port and get all the video packets, and then you need to reconstruct it yourself, or yeah, in the code. Go to a location, and this is like fly in steps. So go up, and not a GPS position in with this one. If you use the DJI Spark or the Maverick or whatever. You can, with Droneblocks, can also do GPS locations. And also with Python, you can do GPS locations. You have some set commands. You can change the speed. So now it was just the default speed, but you can change the speed. And you can change the Wi-Fi, SSID, password, and also even the remote controller. So if you have a Bluetooth controller, you can also set that up using commands. And then you can read commands like you know what the speed and battery and time and height and temperature and even the barometer is. So there are some sensors in there. So if you are flying into a building or something else, or you can also act on the temperature. Oh, it's fire, fly back, or something like that. Or stop, or yeah, just burn. So to get you started, just search Tello on the GitHub. This was last Friday. There were 42 repositories for the Tello. There are some. The DJI has the SDK for the Tello itself, the official Tello. You also have links to a multi-Tello transformations. So even with those guys, you can do a mesh network of drones through Python. And there's also a Python 3 interface because the official one is still Python 2, and maybe you're aware of that, but Python 2 will be deprecated in January 2020. So this will be Python 2.7 will be dead at January 1st, 2020. So if you're still using that, please upgrade to Python 3 for stuff. But so there's a lot of stuff there, and there are also interesting things like using Node-RED for JavaScript. So you can use Node-RED to even do all the plotting and stuff like that. So if you don't want to use Droneblocks, but something like more professional, you can go for Node-RED. Yeah, but also keyboards and stuff like that. So one case, this is what I originally wanted to show. And it was a little bit hard to get it running because of Amazon and connections and yeah. What the idea is, and this is the same thing with the code I have, but it's from how you would do it on your own PC without advanced skeleton stuff. Is this is a post recognition that uses the Tello, and then it gets the stream, and then they have taken things like TensorFlow and the models, and they put it on Amazon on EC2 to do all the calculations, and then bring that back to like the web application running there on the same level. So what it does is basically it tries to get the pose, and it knows what pose it is, and based on the pose, it will send back the commands through the Tello. So you have a thread receiving the video and looking at the video, and then there's a second thread that does the commands back to the Tello. Okay. Let's show that. Okay. Let's go to the code, and let's do that. Okay. Right. So I will make this bigger and high contrast. Yes.
Have you experimented with using 4G so you can use the drone somewhere else?
No, but you might do that if you have like a Wi-Fi 4G repeater. You need to connect to Wi-Fi of the drone. So, but this in this case, and if you have a DJI Spark, it's better to use the controller because it has wider range to the DJI Spark. So you can have like you need to have the controller somewhere, and then that's called by Wi-Fi. Then you have like a MiFi or something like that. I will do the Wi-Fi to like 4G, and then you can have it remotely. But it's like you need to have those two together somewhere. But yeah, I don't know. It's already darker, right? So outside, so it should be readable a little bit. So there are 3 files here. One is the tello.py, and this is the Python SDK wrapper, right? The SDK itself runs on the thing, and this is the Python wrapper. This comes from Tello itself. You don't need to write it. It's there. What this does is, this is the more advanced one. This is the one with the video decoder in it. There's also a simpler one that doesn't have libraries and overhead and things like that. This one is the advanced education version, and the education version can have video. You immediately notice some things. This one will always be on that IP, 192.168.10.1. And the UDP port is 8889, or the IP port, yeah. You can take that, you can do also timeouts and the metric system, what it wants to use. Then it says some things, but what you can do is it creates if you do to connect to the Tello itself, after you have like the connection with the Wi-Fi, you need to send the word command, and the word command it will try to keep up and hold the connection. Then there are some things in the code to have the send command, and the send command, what it really eventually does is it sends a UTF-8 string to the Tello itself on that port. There are things like you can do an abort, you can do a takeoff, and see what it does. It uses the send command to say takeoff. You can set the speed. So with the speed, it is not like speed 10 or 20 miles or meters or something like that. It calculates the round and stuff like that. But this is something you can just look at and it's there, right? You can do rotate commands with the percentage of degrees and rotate counterclockwise. You can do flips, so which way you're going on, where you want to flip to. You can get specific responses. So if you want to get video, you're listening to like packets sending back. And also things to getting the battery, the height, flight time, speed. You can do move commands based on like also the direction and the distance. Move right and move up and stuff like that. So these are the things in the Tello SDK itself or the wrapper itself. Then we have two interesting. There's a Tello control, and this is you can build yourself. This is your control class. This is something if you have like a service layer, then the Tello.py will be your repository, your database where you're writing to, and the util will be your control, your UI, and then and in this case it's even the controller there, the controller to in there, but. They are separated and stuff like that. So the UI is also in here. So if we start this in Python, you can have a UI to fly it on, but also present the video to you. What I see here. Yeah, it's maybe going into too much detail if we really go to the code, but it uses OpenCV to recognize stuff. So it takes the video and then it takes the frames, each frame of the video. It takes frame, and then it calculates what it sees. It doesn't do every frame. It picks just 1 frame per second, and then it looks at the pose. So if you do the image recognition, you need to like wait or stand still for a moment. So to have this code, by the way, it's open source. You can download, you can play it yourself. If you go to Tello itself, they have a simple version of this. This is my own things because I had some problems with some libraries, so I need to change some stuff. But the open source version should work. Or the original one. What you can do is, for example, make like key presses. So because it's a running thread, you can say, oh, based on the key press, I can fly it myself, right? So you can set hard-coded commands, or you make something around it that's where you can interact with. Basically, you can do pause video. You can collect poses. You can also say, okay, I want to do takeoff. So instead of having like doing the takeoff command, you have you can do some code to just wait, and instead of hovering 5 seconds to do a command itself, it isn't necessary anymore. So the hover stuff, it's necessary more because in the code I can also say just wait 3 seconds to do the next command, right? So there's a little bit of logic that you can bring back to the backend. There are some functions there. What you see here is just abstraction layer, right? It's a service layer, and it's something that is like specific or for my application. And then if I call a different SDK, maybe Tello or Spark or something like that, you can change this one, right? If I go to a different SDK. So always have like a control layer on top of that to do stuff. And we also have a pose one, and this has the logic to figure out how I'm standing, if I'm standing like this or whatever. And basically, because this is a different thread running, you want to not block the call back to the Tello itself. So this runs separately. And this is one in the advanced version that I showed in the presentation. This is what's running on EC2 on Amazon itself. But you can see here it determines basically on the points it sees, because it makes with OpenCV you can make a skeleton, and basically on the points it sees, it knows what your position is. Yeah. So if I want to run this, and we see it happening, I need to do the same procedure again, right? And don't be scared, I'm not flying it to you. Maybe I do, but we'll see. No. So we need to do the same process again. I can wait to till I see the Wi-Fi here. Okay, it's there. Okay. So what I'm using is just the main Python, and it starts the video player, and then it also starts the UI itself. Basically, if it's there, yeah. So I can start by saying, no, I'm not saying that. Somebody turned it on. Yeah. You hijacked it. Cool. So it's open, right? So, example. So, okay.
Sorry about me.
No. I know. I didn't know it was you, but thanks. Yeah, cool. So now, hopefully, boots up. Okay. Oh, mobile. So it boots up. So it's now sending commands. So it's sending a command and it sends a stream on. So notes for 5 seconds. Every 5 seconds, it will send a command to keep the connection alive. Right? Hopefully, 5 seconds. So the UI has some things you can do that really easy in Python, saying, okay, this is my screen, and I want to have some buttons there. And I can say to the same thing, take off. Right? And then it waits till it gets an acknowledgement that it's done, right? Okay, the height. Nice, okay. Then what we can do here is we can use commands like, hopefully it works like the arrow is up. It waits till... You playing around again? Yeah, I get some errors already. So, but I can do some flips, hopefully. It's broken again. This is always demos, right? Now, you see it happening, right? It tries to send commands, but it's like try to land it. Okay, that works. So the land works. And let's take off again. Okay. Yeah, see, it gets an error back of a thread. So let's kill it. Okay. 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 So now we're trying to do a rotate. Yeah. But you see that it's command after command after command. I will go higher. I will let's say move up. Move up. No, I'm doing W, right? I'm doing W, but it's like, huh? I think it's because it's not getting maybe the command separate on that. So let's go up. Ah, it doesn't do the up, the W again. No, that's why. It doesn't do the up command itself, so that's not. Okay. No, see? It's the thread is stuck again. So, sorry, but you get the picture, right? What you can do here, and I also noticed there's a problem because the video stream should have gone there, and I had the problem also this morning already that it didn't want to start. It uses FFmpeg, and on Windows 10 it has the tendency to kill itself, and then you need to restart your laptop to get it working. And even if you're doing like a Windows subsystem for Linux, it will not work because it uses the same like libraries on it. So, but you get the idea of like sending commands to this thing and try to fly it, right? So this is like Droneblocks is maybe more easier because you don't have to think about these things and it works or something like that because it communicates differently than Python. But it's interesting for this that you have an external way to control these drones, right? And use them in the field or something like that. So because of time, I would say thanks for coming to this session. I hope you enjoyed it.